In this lesson, we're going to be talking about buffer overflows. Now, a buffer overflow is when you have a chunk of memory and you've allocated some amount of space to it, and the amount of data that you are trying to put into that actually is longer than the amount of space or bigger than the amount of space you've allocated to it. And the reason that buffer overflows actually work is because of the way the stack is put together. Let me bring up the memory layout diagram here again, and you can see the stack frame. Let's say I've got a local variable in a function, and I actually try to stuff too much data into it. What I have the possibility of doing is putting that data into the space in memory where the return pointer is. And if I can manipulate the return pointer in a particular way, then I can have some control over the flow of execution of the program. Meaning, if I can place an address in memory into that exact spot where the return pointer is, I can actually manipulate where the function is going to return to in memory. And if I can also put a bunch of code into memory and send the program back to where that code begins, then I can have the program do what I want it to do as opposed to what it was originally designed to do and what the program and what the code was designed to do. So let's go back to talking about buffer overflows. Let me show you a piece of code here that's actually vulnerable to a buffer overflow. Now, this is written in C, and you don't actually have to understand C, although I'm going to walk you through a little bit. The top two lines are where I'm including some chunks of code from libraries that live outside here. So I'm doing an include for a standard I/O library and a string library. The line that says int main actually defines a function. So main is the function, and it's the function that the compiler knows is going to be the entry point. So this is the place where the program is going to start. So when the compiler puts the program together, this is going to be the entry point for the program. This is that one function. It's a function just like any other function in terms of it getting a stack frame. The difference with this, though, is it's a special function because the compiler knows to do something particular with it. So I've got two parameters being sent to the main function. The first is the count of the number of arguments on the command line, and there's always at least one argument. That one argument is always the name of the program that has been run. So I've got the count of arguments, and I've also got an array of strings with all of the other parameters in it. So my first line in the actual function defines a character array, which is a string, and that string is going to be 10 characters long. So I've only allocated enough memory for 10 characters inside that string. Now I'm using a function called strcopy, and I'm copying the second argument into the string. And you'll see the number 1 inside of the brackets there with argv. And the reason why it's 1 is because all arrays are 0 based. So the first string inside the argv array would be the name of the program, and the second one is the one that we're going to be using here, and that's the number 1 because we would have started with 0. So I am copying argv1 into this variable that I've called str. So I'm using this strcopy to perform that copy function for me. And finally, I am printing out finished along with a string, and I'm passing the variable str into there to be slotted into the space where the %s is. And we'll get into the %s when we start talking about format strings, but that %s is actually a format string that defines the format that printf is going to use to do the actual printing of the data. So I've run the compiler on this. I've got an executable out of it, and I'm going to show you using this. Now I'm going to make use of Perl here. So I'm just doing a simple Perl program. And these backticks, like this one right here, say run what's inside of here and then use what comes out of that on the command line in its place. So what this command line here is going to do is it's going to run that little Perl program, which is just a print statement, and it's going to take the result of that print statement and put it on the command line after this program call buffo. So let's see what happens here. So actually nothing happens here. You can see that I've actually managed to cram 12 characters or 12 bytes into that program space, or into that space where that variable is. So let's try it with some more. Looks like I can do 20. Let's do 30. Here we go with a segmentation fault. Now, a segmentation fault means I have tried to access a piece of memory that I don't have access to, or I don't have rights to. So I've tried to jump to a place in memory that's not actually part of the memory allocation that I have been given. So that's what the segmentation fault is. And that segmentation fault is actually the opening for a buffer overflow attack. So what we've done is we have done a buffer overflow, which actually we did with the 12 characters that we put in. We actually overflowed the buffer, just nothing bad happened as a result of it. It wasn't until we got to 30 characters or 30 bytes where we actually ran into the return pointer so that we were unable to complete the program without a segmentation fault. So that segmentation fault is an indication that something has gone wrong where we've tried to jump to a memory segment that isn't actually part of the program. So that's what a buffer overflow is. That's what goes into a buffer overflow, and that's a small program or a program fragment that actually incorporates a buffer flow in it.